So last week, there was this major, widely circulated headline going around. It boldly claimed that scientists had successfully used a quantum computer to reverse the flow of time.
Oh, yeah, I saw that everywhere. It was, practically inescapable.
Right. People were sharing it, talking about it, totally wondering if we were on the verge of taking, like, vacations back to the 1920s.
Yeah, booking their historical getaway packages?
Exactly. But the thing is, if you actually dug into the physical reality of the experiment, you'd find that absolutely no physical atoms moved backward.
None at all.
No clocks rewound. The universe just continued ticking forward exactly as it always does. So it really begs the question, why are the world's smartest physicists and these prestigious institutions publishing headlines that sound like pure science fiction?
Well, I mean, it creates this very profound sense of modern whiplash for anyone paying attention.
Whiplash is a great way to put it.
Because you're reading the news over your morning coffee,
Mm.
and you are instantly thrust into the absolute outer limits of human comprehension.
Right, which sounds amazing at first.
It does. It feels magical, but it also creates a massive disconnect. Because, you inevitably look up from your screen, look around your kitchen, and realize that none of this supposed time travel or multiverse discovery actually impacts the physical world you inhabit.
Yeah, that feeling of detachment, that expanding gap between sensational scientific headlines and everyday reality is exactly our focus for today. Welcome to this deep dive.
Glad to be here for this one. It's a really vital topic.
It really is. And to help us navigate it, we have a remarkably illuminating piece of source material guiding our conversation today. It's a text from December 2025 by systems developer and critical thinker Edward Gomez.
Just simply titled Math versus Reality.
Yeah, math versus reality. And our mission today is to equip you, the listener, with the ultimate toolkit to navigate modern science news. We are going to decode the mechanisms behind these wild headlines.
And really figure out why we're constantly bombarded with them.
Exactly. And more importantly, we're going to learn how to successfully separate mathematical imagination from actual observable reality. So, okay, let's unpack this.
Well, the foundational premise Gomez puts forward is that modern theoretical science is no longer this closed-loop conversation among researchers.
Right. The days of scientists just talking to other scientists in journals are gone.
Completely gone.
Yeah.
The communication ecosystem has fractured. He points out that modern science actually speaks to three very different audiences now, and only one of them is actually scientific.
Interesting.
Yeah, so to understand why we are being bombarded with claims of parallel universes and time shortcuts, we first have to examine the systemic pressures on the community.
Which means we need to follow the money.
Precisely. We have to look at audience number one, which is the funding machine. We need to look at the economics of modern physics.
Because, the era of a lone genius making a world-changing discovery with a glass prism and a notebook is largely over.
Oh, long over. We're dealing with a totally different scale now.
Right. A multi-billion-dollar scale. We are talking about particle accelerators that span dozens of miles underground.
And require the GDP of small nations just to construct.
Exactly. We're talking about space telescopes that cost $10 billion just to get off the launch pad, and massive arrays of supercomputers running these endless power-hungry simulations.
And that staggering scale, it fundamentally alters the behavior of the entire field.
How so?
Well, to build these massive ecosystems and to keep the research groups running them employed, scientists must secure constant, immense funding.
Right. You can't just build it once and you're done.
No, you're locked in a perpetual cycle. They're constantly writing grant proposals, attempting to capture both political favor and sustained public interest.
Which brings us to a rather blunt observation in the text. Gomez points out that putting a phrase like exploring extra dimensions on a massive government grant application.
It sounds incredibly exciting.
It sounds infinitely more appealing than admitting we actually have no new empirical data to work with since the 1990s.
Yeah, that doesn't really open the checkbooks.
No, it doesn't. But I do want to push back on this characterization just a bit. It almost sounds like he is accusing the scientific community of, inherent corruption. Are we being lied to simply because a laboratory needs cash to keep the lights on?
Well, if we connect this to the bigger picture, it is not about malicious deception or corruption at all.
Okay, what is it then?
It is about pragmatic survival in a hyper-competitive funding environment. The systemic effect of this multi-billion-dollar scale is that it inherently demands spectacle.
because the price tag is so high.
Exactly. If you're a lead researcher, you have facilities that require millions in operational costs. You have dozens of brilliant postdocs relying on you for their livelihood.
You can't just walk into a funding committee and ask for $1 billion to chase a mundane, null result.
No, you need a narrative. You need a profound theoretical framework that makes that massive financial expenditure palatable to the politicians and the committees holding the purse strings.
So these grand mathematical theories basically act as a survival mechanism.
That's exactly it. They provide the necessary what-if that justifies the budget. The funding machine requires theoretical physics to dream impossibly big.
Which creates a continuous pressure to elevate mathematical possibilities into grand physical promises.
Exactly. The system basically demands a spectacle.
So if the economic realities of modern physics inherently demand these spectacular, sweeping ideas, we really have to look at how that pressure warps the actual science being conducted.
Because once the system demands a spectacle, the data inevitably gets stretched to provide one.
Let's return to that viral quantum time machine headline we opened with. I think that is a perfect case study of how this mechanism actually works in the real world.
It really is. The quantum time reversal experiment is just a fascinating illustration of the core problem Gomez is highlighting here.
The dangerous conflation of math and reality.
Yes. The conflation of mathematical representation with physical reality.
Yeah.
In that specific experiment, the researchers were working with a qubit.
And for anyone who might not be intimately familiar with quantum computing architecture, let's just define that really quickly. A qubit is the most basic unit of quantum information.
Right, it's not like a standard computer bit.
No, a standard bit is essentially a switch firmly set to either 0 or 1, but a qubit exists in a state of superposition. It's more like a coin spinning in midair, representing multiple probabilities at once until you actually measure it.
That spinning coin is a great way to visualize it. And what the researchers achieved was the manipulation of the mathematical state of that single, isolated qubit.
Right.
They applied a series of microwave pulses to alter its quantum wave function, effectively reversing its evolution back to its original state.
And within their mathematical formulas, this reverse evolution is entirely factual, right? It's not a speculative calculation.
Oh, the math is totally sound. It happened in the math.
But the crucial distinction here, the reason physics allows this while reality seemingly doesn't, lies in the equations themselves.
Yeah, mathematical equations, especially in quantum mechanics and classical kinematics, are largely time-symmetric.
Meaning they work exactly the same forward and backward.
They are completely indifferent to the arrow of time. In the math, the variable for time, usually represented by the letter t, can be positive or negative.
Right.
The equation balances perfectly whether the event is moving forward or backward.
Yeah.
You can calculate the trajectory of a thrown baseball in reverse just as easily as you calculate its forward momentum. The math simply does not care.
Here's where it gets really interesting, because the physical world desperately cares. I want to build on the source materials analogy here. Gomez compares it to hitting undo on a spreadsheet, but I think we can make the actual mechanism of this even clearer for you.
Oh, I'd love to hear it.
Imagine you're watching a high-definition, slow-motion video of a crystal glass shattering on a coffee table.
Okay, I can picture that.
Because it's just a digital video, which is essentially a complex string of mathematical data, you can hit rewind on your remote. The math of the video player processes the data in reverse, and you watch the shards seamlessly fly back together on the screen.
Right, because the video player doesn't care about gravity or friction or thermodynamics.
Exactly. But the actual physical glass that you just knocked off your coffee table, that is bound by the irreversible laws of physics.
And the primary law governing that physical glass is entropy.
Entropy, right, the observable arrow of time.
Exactly. It dictates that systems naturally progress from order to disorder. The digital video can rewind, but the shattered glass cannot, because the energy used to break the glass has dispersed into the environment as sound and heat.
And you just cannot gather that dispersed energy back up to spontaneously reform the crystal.
No, you can't. Which Gomez actually ties to the concept of chemical asymmetry in the text.
Yeah, let's talk about that. Chemical asymmetry.
It's a profound barrier to rewinding time in the physical world. Biological and chemical processes have a preferred direction because of how energy dissipates.
Right.
Like you can mathematically calculate what a mixture of blue and yellow paint looked like before it became green. A computer can run that simulation instantly.
Just hit undo.
Right. But the actual paint in your hand is permanently mixed. The molecules have bonded in a way that requires massive targeted energy to separate.
So bringing it back to the time machine headline.
During that quantum experiment, no physical atoms went backward. Entropy was not reversed. Only the mathematical state of an isolated piece of data was toggled.
Which makes the author's challenge to these headlines so incredibly sharp. I love this quote. As Gomez puts it, "Show me your quantum computer making my wrinkles disappear, then we'll talk."
It's humorous, but it
And
gets right to the point.
it really does. If you have built a time machine, prove it on biological entropic reality, not inside a perfectly isolated mathematical simulation.
Because the math allows for reversibility, but the physical universe demands consequence.
So this leads us to a critical junction in the text. If the researchers in the laboratory know perfectly well that they are merely toggling the state of a qubit, if they know they are essentially just hitting rewind on a digital video and not building an actual time machine, how does this extremely nuanced, mathematically confined data transform into a global headline about traveling through time?
How does it leak out and become a sensational story?
Yeah, exactly. Who is responsible for that translation?
Well, that brings us to audience number 2. Because researchers need a megaphone to justify those billion-dollar budgets we discussed earlier, an entire translation layer has emerged.
The science PR industry.
Yes, universities and research institutions employ massive PR departments to amplify their work, and their primary goal is visibility.
Because visibility attracts prestige.
And prestige secures the next round of funding.
But the problem with this translation layer, as Gomez points out, is that it applies this Hollywood treatment to deeply complex incremental science.
It really does. The PR machinery takes a highly constrained mathematical simulation of a qubit, completely strips away the context of entropy and chemical asymmetry.
All the messy reality.
All of it. And they package it with cinematic visuals, dramatic headlines, and these emotional what-if hooks.
Because the media ecosystem thrives on engagement, and let's face it, the public is inherently hungry for wonder.
We want the universe to be magical.
We do. We want parallel dimensions to exist. We want shortcuts through time.
And the PR industry caters directly to this desire. It results in a steady stream of highly speculative ideas being presented to the public with the exact same authoritative tone as established bedrock physics.
And this blurring of the line between mathematical experimentation and physical reality is incredibly dangerous, according to the text.
It really is.
Because mathematics is, at its core, an intellectual sandbox. It is an abstract playground governed entirely by logic, symmetry, and balance. In that sandbox, you are practically a god.
You can make the rules.
Exactly. You can build a universe with 10 dimensions or 11 dimensions or 26 dimensions. As long as your equations balance on the chalkboard, the math absolutely allows it.
Right.
But I have to ask, what happens when you are forced to erase those beautiful, elegant equations from the blackboard and actually subject them to the real, messy physical world?
Well, what's fascinating here is that the physical universe has absolutely no obligation to bend to mathematical elegance.
It doesn't care how pretty the equation is.
Not at all. The physical universe bends to entropy. The moment an equation leaves the theoretical blackboard and enters a physical laboratory, it is forced into a brutal confrontation with reality.
It has to survive friction.
Yes, it has to survive decay, irreversibility, chemical asymmetry, the forward march of time.
It has to survive the shattered glass on the table.
It does. A mathematical formula might beautifully dictate that an object can exist in two places at once, or that a wormhole can connect two distant galaxies.
Sure, on paper.
But, as Gomez rigorously argues, we shouldn't grant these concepts the status of physical reality until we observe them. Mathematics can seamlessly describe an infinite number of phenomena that simply do not physically exist in our universe.
Because nature ultimately is the sole and final judge of what is real.
Absolutely.
So what does this all mean for the scientific community at large? If the funding apparatus is constantly demanding grand narratives and the PR industry is systematically stripping away nuance for clicks, what are the actual scientists' audience number 3 doing behind closed doors?
The reality there is remarkably quiet, and it is a reality the public almost never sees. In their day-to-day work, real physicists are overwhelmingly conservative with their claims.
They aren't running around claiming they found the multiverse.
No, they do not operate under the assumption that multiverses or string theories are established facts. They view all of this higher dimensional mathematics strictly as models.
They treat the math as a map, not the actual territory.
Exactly that. When a physicist is presented with a breathtaking new mathematical framework, the consensus position within the community is almost universally, interesting idea, No evidence yet.
But interesting idea, no evidence yet doesn't generate a million views online. It doesn't trend.
No, it's not going viral on social media.
And this brings us to what I found to be the absolute most compelling part of Gomez's text. He roots this entire modern phenomenon, this massive divorce between the math we use to describe the world and the physical observations we actually make, in a deeply historical, ancient, philosophical context.
Yes, the Plato versus Aristotle divide.
Let's really dig into this because this framing changes everything.
It is a brilliant way to conceptualize the current crisis in physics. This is the foundational debates of Western epistemology. Plato was an idealist.
Right.
He believed that mathematics and abstract forms were the ultimate pure reality. In Plato's view, the physical world we walk around in is just a messy, flawed shadow of those perfect underlying mathematical equations.
So Plato would look at the perfect symmetry of a mathematical circle and say, that is the truth, even though a perfect circle cannot physically exist in nature.
Exactly. And Aristotle took the exact opposite stance. Aristotle was the ultimate empiricist.
Observation is everything.
Right. He believed that observation is the only thing that defines reality. To Aristotle, if you cannot touch it, test it, measure it, and observe it functioning in the natural world, it does not belong in the realm of physics.
And the staggering realization the text brings forward is that modern physics is still completely paralyzed by this ancient divide.
It really is.
Because for the vast majority of scientific history, Aristotle was winning. Empiricism ruled. Isaac Newton observed an apple falling from a tree, a physical event, and then he went to his desk and developed the mathematics of gravity to explain the observation.
All right, the event came first.
Johannes Kepler observed the physical movement of the planets in the night sky, and then he wrote the mathematical laws of planetary motion to describe what he saw. The physical observation always came first.
But the paradigm has completely inverted over the last few decades. The text points out that today, theoretical physics has become overwhelmingly Platonic.
The ideas begin on the blackboard now.
Yes. String theorists deduce the existence of extra dimensions purely from mathematical consistency, without ever observing a physical string. Researchers map out the thermodynamics of black holes mathematically long before they ever capture an image of one.
The math completely precedes the physical evidence.
And because the math is so advanced, these blackboard theories are forced to wait years or sometimes even decades for our experimental tools to catch up,
We are just sitting around waiting on the technology to verify the math.
which is the core synthesis of the massive disconnect we are experiencing.
Right.
The funding machine aggressively rewards big, sweeping mathematical ideas. The public relations industry eagerly rewards spectacular cinematic narratives. But reality only rewards empirical evidence.
And finding that evidence is hard.
It is incredibly slow, it is deeply unglamorous, it involves decades of null results, dead ends, and tiny incremental steps.
It is the quiet labor of Aristotle, which simply cannot compete in a media ecosystem designed to reward the flashy dreams of Plato.
The Aristotelian process of actual verification is literally the least visible part of the entire scientific ecosystem today.
So, bringing all of this immense context back to you, the listener, how does this actually apply to your life, and how should you navigate the world differently armed with this knowledge?
That's the real question.
None of this analysis is meant to make you cynical about science. That is a vital distinction to make. We aren't trying to dismiss or diminish the extraordinary, genuine, world-changing breakthroughs happening right now in fields like quantum computing, biotechnology, materials science, or cosmology.
No, bold, highly speculative research must continue because human curiosity is the engine of our progress. The goal of critically analyzing these headlines isn't to kill the wonder of discovery.
It's to protect the integrity of the scientific method itself.
Exactly.
But as a consumer of information, trying to stay afloat in a digital world completely saturated with hype, you have to internalize Edward Gomez's core thesis. Discovery deserves clarity, not fiction.
The actual physical universe we inhabit is already mysterious, complex, and amazing enough on its own.
It really is. We do not need to dress it up with Hollywood fantasy just to feel a sense of awe. Mathematics is an incredibly beautiful language that possesses the power to imagine absolutely anything, but physics is entirely different.
Physics can only test what nature actually allows.
So the next time you are drinking your coffee, scrolling through your feed, and you see a sensational science headline promising you a portal to the multiverse or a quantum shortcut through time, you will know to stop and ask yourself the fundamental question.
Is this just a mathematical spreadsheet aiding undo, or are they showing me actual observable physical reality?
Exactly. And that brings us to a really fascinating place to wrap up today.
Yeah, this raises an incredibly important question, a final thought for you to mull over long after this deep dive concludes.
Laid on us.
We established that in the modern era, ideas begin on the mathematical blackboard and must wait decades for our technology to advance enough to test them.
Right. Waiting for the tools to catch up.
But what happens if our mathematical imagination outpaces our technological evolution permanently?
Oh, wow.
Are we entering a new era where human beings can mathematically prove the existence of phenomena like parallel universes or microscopic extra dimensions that we will simply never possess the physical tools to test in a laboratory?
That is a wild thought.
If our equations become so extraordinarily complex that they can never, ever be verified by physical nature, does modern physics risk permanently crossing the line from empirical science into pure philosophy?